In our last video, we did a dilation construction where we enlarge the shape. This time, I want us to figure out how we shrink a shape. We know that when we do a dilation, whether the shape grows or shrinks or stays the same or shrinks down and vanishes, comes down to the value of the scale factor. And we use the letter K to stand for scale factor. And the way you use scale factor is it's the number that tells you what you do to all the old lengths to give you the new length. So you take the old length, you multiply it by the scale factor, and that's going to give you your new length. So I'd measure some distance related to the old shape, multiply it by a scale factor, that gives me the new length. Let's look at a couple important values of K to remind ourselves what happens. K could be 1, K could be 0, K could be somewhere between 0 and 1, or K could be more than 1. Let's start with K being 1. If I had some old length and I multiplied it by the number 1, I'd get the same number as the result, and so multiplying by a scale factor of 1 doesn't change anything. It preserves the size of the shape. In the last video, we thought about what happens if our scale factor is more than 1. I'd take my old length, I'd multiply it by a number more than 1, 4, 2, 3.7, whatever, multiply it by something more than 1, the result will be a bigger number. And so K greater than 1 causes your shape to enlarge. If K is less than 1 but more than 0, so this keeps it a positive number, but it's less than 1, you take your old length and you multiply it by a half, or a third, or a tenth, or a twelfth, or a decimal like 0.735, anything less than 1 but still positive. I would take some old length, multiply it by the number, let's say a half, and the result is going to be a smaller number. Everything is going to get smaller. Everything will get shrunken down, and this is how you shrink a shape. And you can imagine if your scale factor kept the value of K kept getting smaller and smaller and smaller and closer to 0, you'd have your shape and it would keep shrinking, 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 shrinking until eventually you got to K being 0, and then poof, your shape would disappear. It would shrink down into nothing. As a construction, here's how we do that. We're going to do it to a triangle because that's the most basic polygon, but you could definitely do this construction to any other polygon you feel like or are given. I'm going to bold those points there and label them. This is point A, this is point B, this is point C, and I would like to do a dilation centered at P with K equals, I like to write my fractions like that, a half. So let's put point P right there. There's P. When it says the dilation is centered at P, it means you are going to dilate the shape, so either push the shape away or pull the shape in relative to point P. Since we're looking at a scale factor of half, the first thing you should start predicting is this number, half, is less than 1, and therefore I'm going to expect my shape to get shrunken down and pulled towards point P. You can imagine that there are strings coming out from point P that grab onto the vertices. So one reaches out and grabs A, one reaches out and grabs B, one reaches out and grabs C. Let me just darken these sides so it's easy to see what the triangle is, or what part of this is the triangle. And these strings come out, and then you grab the strings and you start pulling on them. And when you pull on these strings, everything that you see over here gets dragged towards point P. You're going to drag these points in so that whatever distance you had here gets cut in half. The scale factor was a half. Whatever distance you had here needs to get dragged in and cut in half. This distance here needs to get pulled in and cut in half. We know how to cut things in half using constructions. We know how to find midpoints. We do it using perpendicular bisector. If I wanted to find the midpoint of this, which would be half, I would center my compass here, open up more than half, put an arc. Flip around to this side of the segment, put the exact same arc, connect those intersections, and get that point there, A prime. By bisecting this segment, by finding the midpoint, I've taken this length and I've cut it in half. I'll do the same thing to this segment. I'll extend the compass out more than half, put an arc. Flip around to this side, put the same arc. Connect them, get the midpoint, there's C prime. Do it to this side. Open the compass up more than half, put an arc. Flip around to this side, put the same arc. Connect this. That doesn't look perpendicular, but it will when we do the construction. That is your new C prime. Connect these vertices. And you will have taken your original triangle A, B, that's not C prime, that is B prime. A, B, C, and you grab this triangle and you shrunk it down. It got pulled in towards point P and it got shrunken down by a factor of 1/2 to make this triangle. This all belongs in your notes. Let's do the construction with a compass and straight edge now to demonstrate. I'm going to start out by just sketching in some triangle here. Let's go with that. That. There. And I'm going to put point P right there. So I'm going to do a dilation centered at P with K equals 1/2. A, call this B, we'll call this C. There is a segment I can add in here that connects P to A, that connects P to B, and connects P to C, but this straight edge won't reach. Will this one reach? Yeah. So we'll connect those. And now I'm going to use my compass to do a perpendicular bisector to this, to this, to this, find those midpoints and connect them. So let's start with this one here. I'll go to this point, center the compass, open up more than half, put an arc, flip to this side, put the same arc. Here's an intersection, here's an intersection. I connect those intersections and it gets me A prime, which is the midpoint of AP. So I've taken AP and I've cut it in half. I'll do that to CP. More than half, that looks good. And you can see the nice thing about doing constructions with a pencil is I can make things as dark or as light as I need. Like I'm making these construction marks a little light. I'm just going to extend this so I clearly have the intersection. I'm making these construction marks a little light so that they don't distract from the final image, the final figure. There is the midpoint, C prime. C prime is the middle of CP, so I've taken CP and I've cut it in half. And now I'll do this same thing to BP, center myself here, go more than half, flip around to the other side. And there's a lot going on here, so we have to be careful and make sure we connect the right points. So here's the arc, there's the arc, so I want that point, and then I want that point. I'm going to connect them to get the midpoint of BP. So there is B prime. That point is a vertex that came from there. That point is the vertex that came from there. That point is the vertex that came from there. All I have to do now is connect these, and I get my dilated triangle. And there we go. This triangle ABC relative to point B was dilated. It was shrunken down. All the distances, all the lengths got cut in half, and they all got pulled in towards this point P.